good afternoon, good evening to you all, depending on where you're signing in from. Thank you very much for joining me today for today's Space Catalyst Community Webinar. My name is Jonathan Yakasha. I am the Principal for Open Innovation with TechConnect. I'm going to be your host for today. And today we are going to be discussing artificial intelligence and data solutions for LEO. I've got two great speakers to chat with today. First off, we have Justin Pierce, Strategic Development Officer with BAE Systems. Justin, give our audience a nice little wave for you. And we also have Nick Ansell, Principal Space Solutions Architect with Amazon Web Services. Thank you both for signing in today. Appreciate your time. So before we get underway here, folks, a few quick housekeeping items before we get underway. To begin with, I'm going to spend roughly the first half of today's time asking my guests about their assessments for how AI is impacting commercial LEO operations. At any point, though, if you've got a question, go ahead and use the Q&A chat box to submit your questions. During the second half of today's webinar, I'm going to get to those questions, and I will pose them to Nick and Justin. One quick note that I will say right at the outset here. In an open webinar format like this, questions about specific technologies or programs are going to be difficult for my guests to answer. So please keep that in mind when you are formulating your question. I absolutely want a ton of questions on an array of topics, but I also want my guests to actually be able to answer them, and I know that you do as well. One final item before we get underway with the questions. So in a little less than a month, TechConnect will be hosting a live pitch event at Defense Tech Connect on the topic of AI for space operations. 10 companies operating at the intersection of AI and LEO will be competing to be part of the AI SATCOM launch vehicle program. So if you're interested in seeing those companies pitch, maybe doing some networking yourself, check out the Defense Tech Connect conference page on techconnect.org and consider registering to attend. We'd love to have you out there. So with all of that out of the way, and without any further ado, let's go ahead and get started. So Nick, Justin, can you give our audience a quick summary of the services your organizations provide and your specific role within your organizations? Nick, how about we start with you?
Happy to, thanks. So happy to be here too. Thanks for the invite. So I work for Amazon Web Services, or AWS. And for those that don't know, AWS is a cloud services provider. My role in AWS changed recently, actually. So you were right to say I was Principal Space Solutions Architect. I did that for a number of years. More recently, about just over a month ago, I moved into a BD role. So I'm now the lead business development on the space and SATCOM side. In terms of what our customers do or the services that are available, I get to work with lots of interesting customers doing some pretty cool things, either in the space industry or using space technologies in some way or other. So some organizations are building their entire businesses on top of AWS services. Others are communicating with their satellites using the AWS ground station service. Others are processing Earth observation data, for example, using compute, storage, machine learning services. And then others are literally reimagining their business, what they can do today with agentic AI solutions. So, for example, using agents to optimize their space mission planning, or building some really cool conversational interfaces into some pretty deep technologies. So, for example, talking to an orbital simulator, build me a satellite with 700, 8,000 satellites. Here's the orbital elements. Tell me all the make or break points between that satellite constellation.
Okay, great. Thank you, Nick. Justin, how about you?
Yeah, thanks for having me, Jonathan. So I'm on the strategic development team here on the space side of things at BAE. As many of you probably know, BAE is a prime contractor, and on our space side of things, we execute a number of space missions for some civil and defense customers. We do everything from we'll build the entire space vehicles, we'll fly them, and then we even have some ground components available kind of in our business architectures there. So we basically do the whole thing depending on the mission and what our customer is looking to do, and can do the whole thing. My role focused on what technologies we need to focus on in the next 2 to 10 years, and really ensure that we're setting ourselves.
Justin, I think we might have lost you there. All right, folks, I apologize for this. It looks like Justin's internet connection may have dropped him a little bit there. So we're going to go ahead and proceed and hope that Justin is able to rejoin us shortly. With that in mind, Nick, I'm going to put you on the hot seat.
Okay,
So,
cool.
Justin, are you back? Okay, not yet. All right, so Nick, to begin with, are your teams able to help early stage companies figure out if and how they might be able to use AI in their missions?
Yes, in lots of ways. I see Justin's back.
Welcome back, Justin.
Yeah, Justin, I think you may have been stopped in your track, so please go ahead.
Yeah, please.
Yeah, where did I stop?
You were just about to discuss your role in BAE.
Gotcha. Yeah, so I'm really focused on kind of the next 2 to 10 years, and really ensure that the technologies that we're adopting and looking at are readily available and in interest to ourselves and to our customers.
Okay, great. So the question I was just posing to Nick was if your teams are able to help early stage companies figure out if and how they might use AI in their missions. Who'd like to go first?
I'm happy to go. I've got the
Go
mic.
for it, Nick.
Thank you. So yes, our customers are using, well, I would say many early stage customers are using AWS services, but I would also argue that it's not just early stage customers that are doing rapid experimentation. So all sorts of organizations that we're working with, from the most mature to the startups, are doing all sorts of cool things. And I guess in general, I would say cloud computing services, or cloud services in general, are really well suited to rapid experimentation. So you literally log into your account and then you start creating resources. So you're sort of innovating as fast as you can think, in a way, rather than waiting for servers, storage, networking, etc. to be provisioned. More specifically, for customers wanting to do machine learning services, so basically to try things out or to build machine learning pipelines, we have a service called Amazon SageMaker that some customers may be familiar with, or some of the audience may be familiar with. For agentic AI solutions, which we're seeing a lot of use on, we have the Bedrock service, which is essentially a consistent interface into lots of different, well, a pretty broad range of large language models. For customers wanting to deploy agentic AI solutions into production, we have a service called Bedrock Agent Core, and that essentially is software defined, as are most things in the cloud. You tell it you want to deploy into production, and then it wraps it in all sorts of guardrails that you would expect, sort of high availability, security guardrails, etc. On the hardware side, our customers have access to the latest CPUs, GPUs, etc. Also, that includes AWS custom design silicon, which often provide a really good price performance point and a really low energy footprint. So having access to all of those capabilities, our customers are doing all sorts of cool things. So one particular thing, in addition to just rapid experimentation of almost anything that you can think of, a lot of our customers are building out cloud-based test environments to simulate different parts of a space environment before they launch things up into orbit and they start flying.
Sure. Justin, how about your team? How do you guys interact?
Yeah, there's a number of things that we do similar to what Nick is saying, or we use what they're putting out there. But for our sense, we're solving mission use cases of putting edge compute on a satellite, using it to have an agentic way of talking to the subsystems and such, and using that to analyze what's kind of going on. So there's a number of things from on edge in space to also on ground, and looking at telemetry or understanding routing paths and stuff like that. Some of these cases are internally funded of things that we're doing with AI, but also we often look externally and partnering with others if they have some interesting technologies and use cases for AI.
Okay, great. So you guys have touched on this a little bit. Broadly speaking, how do you see AI influencing commercial space activities across hardware selection, mission planning, data management? Justin, why don't we start with you this time?
That's a good question. Definitely seeing things on all three of those that you mentioned, on hardware, faster processing ability to do in radiation environments, which is often a tough one when you go outside of LEO. But also, we have access to processing that may not meet the needs of terrestrial AI, and you have to load a model that can kind of be hosted on a processor that you wouldn't think of using for an AI model. So sometimes the simplification of our AI needs are really interesting on the hardware side. Also for the mission planning, there's a lot of different ways to automate and utilize AI to help the space operators on that side of things. There's the classic example of, we may stand up a team that has, somebody at the desk all the time or multiple people at the desk flying a satellite, but then you may see a Starlink where there's a couple of people flying. I think they now have over 10,000 satellites on orbit. And then also, managing the data that comes back down to Earth is a key aspect of this. And one thing that we're really trying to utilize is understanding the insights that our spacecraft are giving us on orbit to better decide what we want to downlink. As everybody probably knows, ground stations only come at certain times during your orbit, and the time that you have to downlink is quite precious. So if you could fill a lot of that time with more important data, that's often a really big thing for us.
Nick?
Yeah, so on the hardware side, I haven't seen AI, me personally, haven't seen AI influencing hardware design. I have seen hardware design influencing the AI side, though. So as Justin mentioned, in terms of operating inside versus outside LEO, we're seeing a lot of investment in LEO at the moment and a big shift from GEO down to LEO. Of course, satellites operating inside the Van Allen belt in low Earth orbit, they're subject to a lot less radiation events, and that's causing a shift from traditional rad-hard, radiation-hardened hardware, to radiation-tolerant solutions, which are essentially taking off-the-shelf hardware and then applying a lot of radiation to it, and then seeing what fails, and then tweaking certain things. And we're also seeing a trend for more and more space-ready, radiation-tolerant hardware solutions available. So the likes of Intel and their Starfire SoC, the NVIDIA Space Ready range. And we also saw, which I thought was quite interesting, a StarCloud flying an NVIDIA H100, so a typical GPU, but instead of going down the radiation tolerant route by manipulating the hardware, as far as I know, I wasn't close to the mission, but they used essentially new thermal management and then new radiation shielding technology to allow the use of sort of regular GPUs up on orbit, which I thought was cool.
Okay. Let me ask you both. Oh, sorry.
Yeah.
I thought you were done there, Nick. If you have more, please continue.
So I was going to comment on the mission planning side next, Jonathan, but if you have a question.
Yeah. Okay. No, go for it. I'll wait.
Okay, cool. Thank you. So on the mission planning side, I sort of alluded to it briefly before. So there's quite a lot happening on the ground side and on the orbit side, certainly in my visibility. So the ground side, I alluded to it before, customers building agentic AI and traditional machine learning applications to optimize simple things in some ways, but they can get quite complicated quite quickly. So simply acquiring data from on orbit and then bringing it down to the ground can be pretty tricky with a number of satellites, a number of ground stations, etc. So machine learning applies to that really well. On orbit, however, I'm seeing more. So one, in fact, a few common uses. So one, satellites, of course, have limited storage. So satellite operators have to plan their missions based on that limited storage. When are they going to essentially downlink and offload and then free up the storage, then they can fill it back up again. So one application, of course, as you alluded to, Justin, is running some form of machine learning on orbit. And at the simplest level, that machine learning can determine which data is usable and which isn't. So in Earth observation, we get things like clouds in the way, or the look angle's not quite right, or whatever it is. So being able to quickly determine either all of the data is rubbish, throw it away, or this data is usable, this data can be discarded, that can free up space pretty quick. And that will allow satellite operators to essentially have a lot more freedom in their mission planning and probably be able to utilize the space assets more. But I think the biggest thing on the data management side for me is the ability for on-orbit ML to reduce the size of the data. So for example, we can task a satellite with specific tasks. Let, for example, find wildfires or extreme areas of extreme heat in certain fields. And if we compare like the traditional method, like satellite captures data, satellite downlinks the data using one pass or several passes, depending on the data that's coming down and the quality of the pass. Then the data is processed and then analyzed, and then if there's a particular insight, the notifiers are operated. If we do some of that on orbit, we can compress that. So essentially, the satellite captures the data, the satellite processes and analyzes the data, and then if the satellite finds that area of extreme heat or whatever, it can reduce that insight down to literally area of extreme heat, here's the lat long, and then with that reduced data, get it to the ground much quicker and then notify operators much more quickly.
Okay, great. Thank you both for that. We've got a number of questions that are starting to come in. Audience, keep them coming. Like I said, I want as many good questions for these two guys as possible. We're going to get to your questions in just a little bit. Justin, Nick, when the entrepreneurs and researchers in our audience are thinking about their LEO ambitions and AI usage, what sort of things do you want them to keep in mind? Good, bad, and otherwise.
Yeah,
Nick, let's start with you. Oh, sorry, Justin out the gate. Go for it.
Sorry, Nick.
Go ahead.
Wait for Jonathan. No,
Yeah, go ahead, Justin.
Yeah, there's some, like, honestly, there's some really, really cool things that I've been seeing around, you know, online or in the news, space news, payload space, etc. But a lot of times I question myself what the application is for when understanding some of the customer pain points and kind of seeing the mission need. So really want to tie it back to the customer and, you know, helping solve pain points and providing exponential value to something that they are specifically doing. There are some niche and novel ideas, you know, that nobody's been using AI or using because of space limitations and stuff. So I think like data centers is a great example. So that will be great, but I think the key is really understand the mission set and also identifying then your customers and folks that you're helping out with what you're providing.
Yeah, I think you make a great point. You can do so many cool things. You need to sort of focus your attention to make sure you're doing the right things. I guess I would answer it in a completely opposite way. I would say be as creative as you like, but also be creative while bearing in mind some of the complexities of operating things in the space environment. So there are all sorts of things that many entrepreneurs, researchers, software developers perhaps have not had the chance of experiencing, such as on the hardware side, you know, hundreds of degrees swinging, plus and minus, radiation events, vibrations from launch vehicles on the hardware side. And then on the software and the sort of mission design side, many organizations haven't had to deal with orbital dynamics and the frequent make and break between connections, not being able to talk to your satellites as frequently as you thought. And then even down to the reliability of radio frequency links. Like, they're not always as reliable as you design them. There are sort of atmospheric conditions that can increase latency and loss. And many people start with the premise that all those things don't exist. So I would recommend be creative, but bear in mind that there are several things that you need to be aware of to sort of limit or guide your creativity in some way or other.
So the balance between the two of you is be creative, but also be aware of justification in physics.
That's a good shout.
Okay, all right, great. So entrepreneurs, researchers, keep that in mind when you're designing your things. Be really creative, and Nick will be happy. Keep it based in physics and reality, and Justin will be happy, and everything will work out perfectly. All right, folks. Keeping on that early stage company focus, what do you think those early stage companies, those early stage entrepreneurs, what do you think that they misunderstand or overlook when it comes to figuring out the role of AI in their mission? Nick, let's start with you this time.
Happy to, yeah. So when it comes to the role of AI in their mission, I think we touched on some of the points in terms of being specific and making sure that you're doing things right. More generally, I think there are several things that are often overlooked, or not necessarily overlooked, but customers are often indexing a little bit too much on some things and then under indexing on others. So, for example, size, weight, and power restrictions. So I ran a program a while ago to put machine learning up into orbit. And I remember sitting my machine learning engineers down and just talking through, they may be used to this type of hardware on the ground, and they may be used to having all of this available. Up on the satellite, you are going to be severely resource constrained. So you need to plan and design for that. Other areas, I think lots of organizations, certainly new organizations, they're focusing on things like satellite manufacture, payload design, their orbital regime, launch provider, etc., but maybe aren't spending time early enough thinking about what type of radio they're going to fly, what ground stations they're going to use, what radio frequency spectrums do they need in particular geographies. So sometimes that's a bit of an afterthought, which will cause issues for any mission, regardless of how good the on-orbit technology is. And then another point I would probably say, and this might be the most important one, is how are your developers going to manage your applications on orbit? So when you consider there are, Google it, you'll probably get a different number, but maybe 30 to 40 million software developers out there in the world today. And the number of those that can develop applications and manage applications in the space environment, you could probably fit into a single football field. So there's a pretty small talent pool. I would therefore argue that many organizations need to think not only about the hardware design and the machine learning or on-orbit AI application, but how those applications are going to be managed. How do you deploy them safely? How do you update them? How do you retire them? I think the organizations that are going to be really successful are ones that abstract some of that complexity away. So software developers, they don't necessarily need to think about all of the orbital mechanics, the make and break, what's happening on the space side and how reliable the hardware is, etc. They can focus on developing features, developing functions, developing bug fixes. If they get that right, then essentially they have a much larger talent pool of software developers to recruit and then do some really great things.
Justin.
Yeah, no, Nick brought up some great points, and even some of the points you were talking about in the previous question, Nick, like even just the fact of not having 100% ability to connect to what you're trying to do. You know, a lot of people are so used to just typing in the terminal and hitting a reply back or something, or transferring a model over Ethernet speeds and not even remembering that, oh, if I want to push this model up to my spacecraft, you know, I might have a 1 megabyte per second connection up to it. And oh, by the way, I only have that, you know, 20 times a day and 10 minutes each on average. So just kind of really thinking about the complexities of the orbits, the things that you're trying to do, and then also, you know, tying that back to the customer is the key point of understanding, hey, what am I solving in the time that I'm taking up to upload, you know, a new patch of software that we could be uploading a mission or providing, you know, bringing back data to catch those wildfires, to go back on that example. You know, instead, are we having to downlink, you know, different tools and understand what's happening with our model, or is it working and providing the data that we need?
So once again, being aware of the physics of what is going on and not trying to break the laws of physics just because you've got a really cool idea.
Yes.
You're not wrong.
All right, thank you very much for that, Nick. Just kind of looking backwards at things that people have done, companies have done. I want to ask both of you in the little bit of time we have for the first half of our webinar here. I want you to look forward. Looking forward, what do you each see as the future of AI when it comes to commercial space? Either new applications or just new things that you think that the AI will be able to help with. Justin, how about we go with you this time?
Yeah, sure. No, so this is where I really like the thought of what Nick was saying of being creative. And there's a very interesting future that we're about to face. When you have the ability to launch 1,000 times a year, let's say, there's a lot of predictions that will happen by 2030 at least, and the United States is kind of preparing for that. But what does that also bring? Well, that's thousands and thousands of spacecraft as well that will be carried up to orbit, maybe even up to cislunar space on lunar missions and all of this type of stuff. So what I really like to think about is, can AI fulfill various things that we're doing right now, but in massive quantities of spacecraft and things that you can't just spend a lot of time on for the onesie-twosies that we currently do a lot of times, or what paperwork is monotonous, what FCC licensing really sucks to do, what launch licenses, all that kind of stuff. What tasks can we simplify with AI, on orbit? And then also, can we navigate? Can we optimize trajectories while we're on the edge without having an operator tell a spacecraft what to do? Stuff like that is kind of interesting to think about as you look to the just sheer scale of what things could be, in the next 10 years. It's quite fun to think about.
Justin, great, thanks. Nick.
I think you made some great points about scale, and we're certainly seeing crazy numbers at the moment, aren't we, with filing. So I guess one of my predictions for current trends that are going to continue, we're going to get more and more on-orbit compute, on-orbit machine learning, and that's going to keep growing. So Starlink filed for 1 million orbital data center satellites recently. StarCloud, I think 88,000, Blue Origin 51,000. Those numbers are huge. I would also probably guess that with those numbers, it's not just those organizations that will be using that capability. They will be building all sorts of different functions to provide that capability to other customers. So if you want to do any form of machine learning, AI, whatever it might be on orbit, you will no longer need to design your satellite and go through all of those processes and then operate the satellite and launch, etc. You will be able to buy the capacity sort of more readily available, like cloud services actually. I think the hardware trend will also continue. There'll be more powerful hardware available. I think a continuation of the radiation tolerant versus radiation hardened design. So we'll see more modern hardware used, whereas traditionally rad hard was sort of quite old and the evolution, the cycles were quite slow. In terms of new things, I think I'm going to be a bit more creative, going back to my point from earlier. So I think we'll see the offload of space data processing between satellites. So we'll see more and more inter-satellite links appearing. We're seeing them go way beyond theory now, and we're seeing those used. So we'll have one satellite that maybe thinks it's in an area of extreme heat, for example, and then request the help of another satellite to raise the confidence score on that. Maybe another satellite is flying different instrumentation or a different look angle or whatever it might be. I think that trend might also continue beyond satellites. So quite soon, I think we'll have a number of orbital space stations with more storage, more compute, etc. And we're likely to see either manual or automatic offload of data processing tasks, etc., from satellites to space stations, for example, or other satellites. And then picking up on your point, Justin, about Luna, I think this is quite a big one. So at the moment, when we say bring the data to the ground or acquire data from space, we're almost always thinking the data starts on an orbiting satellite, and then the data ends on Earth in a data processing pipeline somewhere. But I think more so, the destination will be somewhere other than Earth. So lunar orbiters, lunar stations, maybe bouncing off GEO to get out to LEO. So I think we'll see more and more of that.
All right. Final scripted question that I've got for you guys is a question that I am sure that audience members are curious about. If they want to engage your organization's services, what is the best way to go about doing that? Nick, let's start with you.
I guess 3 ways come to mind. The first one, go to the Amazon Web Services website, create an account, and then you've already got access to one of the best Lego sets in the world to start playing with. In addition to that, AWS partners are doing great things. So you can often utilize AWS services without knowing it through a partner or knowingly, and then AWS partners are building all sorts of technology solutions on top of AWS. Additionally, if you want to get there quicker, then AWS partners are offering consultancy services. And then finally, there's AWS Professional Services, or ProServe. ProServe is pretty much a global team of engineers with expertise in almost every field that you can imagine. So another great way to accelerate your mission. And also bear in mind, ProServe have access to, or direct access to, AWS service teams that can often accelerate where you want to get to.
Great. Justin, how about if somebody wants to engage BAE?
Yeah, I guess for me specifically, feel free to reach out on LinkedIn is often a great way, and then can kind of funnel in and narrow down some solutions that we're looking for with what you might have offering. If it's something that we need, I'll definitely try to engage, and often get inundated there with lots of messages too. So if it's something you think we really need, feel free to keep pinging me, but don't get too annoying. But yeah, that's probably the easiest.
All right, great. Thank you both for that. Audience members, now it's your time to shine. I've been peppering these two guys with questions that I've come up with that I thought you would want to know about. Now it's time for the questions that you folks actually have. And you're not disappointed. We've got a number of questions coming in. We're going to take the rest of our time to answer your questions, so keep them coming. I'm going to go through as many of them as we can. As I said at the outset, please bear in mind that in an open webinar format like this, it's going to be difficult for Nick and Justin to talk about particular technologies or programs, so keep that in mind when you are formulating your question. But I'm actually going to violate that disclaimer right off the bat here. Nick, what was the name of that AWS AI service again? That was the very first question that we've got here.
So there are several. So for traditional machine learning, ML ops, Amazon SageMaker will be your friend. For agentic AI solutions, there is Amazon Bedrock, so consistent access to a broad range of LLMs. And then for deploying, I'm just picking a few here, but the ones that I mentioned before, I could probably go on for ages telling you about all the different services. The final one I'd mention is Bedrock Agent Core. So if you want to deploy agentic applications into production with all of the guardrails, etc., then you would use that service.
Great, thank you, Nick. All right, so our next question. Do you see a shift from applications that humans operate to intelligent systems that are operating on behalf of humans when it comes to space industry applications? I think I see Justin already nodding there.
Yeah, no, 100%. Oftentimes, the classical way of flying a satellite is to wait for the next pass. You collect some telemetry of what it sent down to you, and the analyst looks at said telemetry, maybe the data or pictures or something that it's done, and sends up a new command, and then waits 90 minutes for another pass to see how it did. Oftentimes now value is being created because we have solutions that can do things on the spacecraft and make decisions when an operator is not in the loop, right? So understanding how that happens and how it reduces the strain on an operator in those 10-minute passes can do a lot for us. But yeah.
Nick, anything you want to add?
Yeah, I think that's a great point. I touched on some things before. They were sort of more predictions in terms of satellites sort of tipping and queuing each other, and then essentially having an autonomous conversation about confidence scores of observations, etc. An area that we didn't touch on actually is rendezvous and proximity operations. And in many cases, those or many of the operations associated with that are autonomous, that there's no human in the loop in some cases, mainly because of the latencies involved. And then when we talk about landers, so lunar landers, there's hardly any humans in the loop, again, because of the latencies. You've got sort of 2.6 seconds round trip time, so you're not necessarily going to be able to control a lander. So yeah, I think that's the trend that's going to continue.
Talking about space operations, talking about AI, we're talking about data. What about protections against cyber attacks on autonomous control, TT&C, collision avoidance system, to piggyback off of your rendezvous operations comment there, Nick?
Yeah, happy to take that. For me, I mean, I've been doing security with services on the ground for a long time, and I would argue that many of the same paradigms apply to the space segment, but are not yet applied fully in some cases. So things like identity and access management, of course, that's important. You need to be able to control who has access to do what. Things like automated threat detection. So looking at logs, looking at activities and identifying potential security issues. I would probably argue all of the same paradigms apply. However, some of them need to be modified slightly when we consider satellites being up in orbit and the possibility for physical objects to interfere with the operation of that satellite. So there are certainly new things that we need to consider, going back to the physics points from before, but I would argue the best place or the best way to secure a space mission is to start with everything we've learned on the ground for the last sort of 20, 30 years, apply that well, and then think about what's different.
Just anything you want to add?
Yeah, I don't have too much to add, and I think Nick answered that really, really well. Just the one thing to kind of hit with a hammer is to understand, the potential things that you have on the ground that you don't have access to on space just because of the timing of events and stuff. So like Nick was saying, the trusted architecture is fault detection and responding to it when you don't have access to ground stations is all really important.
Actually, one of our questions here, Justin, kind of goes back to that trust. What does the role of trust and confidence in AI outputs look like in satellite to ground or satellite to satellite communications? Can you both speak on that for a little bit?
Yeah, I'll take a stab at it at first. A lot of it, I think, is a crawl, walk, run approach that could be taken. There's to ever so closely edge ourselves back and let AI take some more control, or where we can trust it. As humans, we're often prone to not trusting in stuff. So just allowing us to take some very good step approaches to understanding exactly what is being told to us by whatever it is a good step to making sure that you don't just go try sprinting and then all of a sudden you have a spacecraft that thinks it needs to dock with the ISS or something like that.
Great points. In terms of trust, I think that's a really interesting question. And I guess I will sort of answer using traditional paradigms. So we trust machine learning models because we have spent a good while training those models on data that we trust. In addition, we monitor the outputs of those machine learning models, knowing that they can drift over time. And then we refine and retrain and then update those models to sort of keep the confidence scores in line with what we expect. Additionally, though, we are seeing the use of agentic AI systems more and more. And traditionally, they have been less deterministic than traditional machine learning models. In the early days, we saw a lot of hallucinations, and the trust level working with an LLM was quite low. But honestly, I'm seeing that change rapidly. But when developing agentic solutions, I think two things are important. One is it's all about the evals. Speak to any AI researcher, they will tell you that you need to build the right evaluations and the right testing frameworks and harnesses. So agentic solutions produce the results that you want and you have a high confidence in them. Another method that I use quite a bit is providing those agentic solutions with the right tools via MCPs, for example, the Model Context Protocol. So you're providing an LLM with tools that are really deterministic, like physics models that have been around for a good while, for example. And then when we provide those LLMs access to those very deterministic tools, we see much more accurate results and much more repeatability of those solutions.
Great. Folks, we don't have a whole lot of time left with Nick and Justin. If you've got questions that you would like to pose to them, now would be an excellent opportunity to do so. So take advantage of the opportunity. I've got a couple other questions I'm going to ask them in the meantime. Looking at the audience for today, Nick, Justin, we've got a good spread between academic researchers, government representatives, private sector folks. Do you see any noticeable differences in the type and familiarity of AI deployment that you see across those three, or is everybody kind of on a level playing field?
That's a tough one, isn't it? I think there's so much diversity in all of those sort of community groups that you've mentioned. I would honestly find it difficult to say government organizations are always like this, commercial organizations are always like that. So honestly, I think I would find it difficult to answer with a high degree of confidence. What I do see is an amazing amount of interest, investment, and creative thinking in that area from all of the customers that I'm working with.
Yeah, I think I'd agree with Nick. I don't think anybody is ChatGPTing better than somebody else, for instance. But I think what I would also relate to is a lot of folks have access to similar tool sets right now. We all have the same or very similar sandboxes to play with and stuff. So it's just imagining what kind of tools are we going to use to play in that sandbox, and how are we going to turn that sandbox into something useful. I think is where the differentiators really stand and stuff. So you'll see, companies and startups that seem to have very good ideas, just not, produce really anything at all and had a nice PowerPoint pitch deck. But then you'll see some companies that have been doing some amazing work and don't even have a pitch deck at all. And you're wondering, hey, why aren't you raising money, or why aren't you trying to grow this and bring this to the masses, et cetera. So I think it's a wide range for all of that, like what Nick was saying.
All right. We are just in the final couple of minutes here. I want to thank both Nick and Justin for taking some time out of their days to talk with me and talk with all of you. Hopefully you all have had the opportunity to learn a bit more about what BAE and AWS are doing when it comes to AI in commercial space operations. Likewise, if you're interested in utilizing AWS and BAE for your LEO dreams, you know how to get in touch with them. I think they would love to see a spike in people asking them, hi, how do I take advantage of what you guys are doing? To our audience members, thank you all for signing in. I really appreciate your questions. Hopefully you'll come back for the next Space Catalyst Community webinar. Nick, Justin, thank you guys for being here. Appreciate you taking the time today. And we'll talk again in the future. Have a great rest of your day, everybody. Bye-bye.
Thank you. Bye.
See y'all.